Cool. 732, My Calendar 3. Implement a My Calendar 3 class to store your events. A new event can always be added. Your class with one method, book, start, and end. Formally, this represents a booking on the half-open interval start, end. Uh, okay. Yeah, which side is the inclusive one? But okay, the range of real numbers x such that x is less than or equal to x, which is less than n. A k-booking event happens when k events have some non-empty intersection. There's some time that is common to all k events. For each call to the method myCalendar.book, return an integer k represents the largest integer such that there exists a k-book in the calendar. Okay. Well, let me go back to Python just because I should practice this more. Python. Oh yeah, and feel free to ask questions if y'all have any questions while I'm doing this. But cool. First two events can be booked at this joint. Is it all just book? Okay, so there's no like delete events. And for in this extra first event, the maximum cable is a 2 booking. Okay. Okay. It shouldn't be too bad, I think. I think the thing that I always look for when I see these problems, which actually didn't happen in the previous problem because they didn't have a section for it, is kind of look at the constraint as much as I can. So gravitate that there'll be only be 400, so 400 cores, which immediately sets off things in my head that like, okay, now I could probably do things n square, maybe even n square log n or something like that if necessary. I don't know if this applies here, but yeah, well, n square log n total. So in theory, you can do a sort on everything. So like you could do an n log n per book core, maybe. I mean, I don't. I mean, that's probably like the ceiling of what we would need to do. I don't know if that's the right complexity, but of course, the end sign. Okay, and it contains start and end. Okay. Yeah, I mean, I think that that. I think so. The only two, to be honest, there are only two questions for me. One is trying to figure out if I want to do a heap or a regular sort on each of these cores. As we mentioned, we could do n log n. We have probably about n log n time. Yeah, damn it, John. Now, I mean, you're exactly right. I was thinking about that exactly. Yeah, we just need to sort and encounter overlapping segments. I think, yeah, the only, like I said, the only question I have is maybe, and I guess in some way they're both sorts, but like, oops, what did I click on? But like whether you just sort the entire thing every time, or what you call it, or maybe put in a heap to kind of save some time. Can we put it? Should we put in a heap? Yeah, I think there's some benefit in putting a heap, even though they're both n log n. At least you don't have to resort. I mean, essentially that's what you're doing with insertion. So I think that saves us some time. Yeah. You can also insert in order. Not quite sure. Oh, you mean like uh, uh, what you call it? Not really insertion sort, but the thing with inserting things in order, it's kind of tricky to do necessary because either you do it on a linked list type thing, which allows all of one insertion, but then you get like an n square type situation. But maybe that's fine. No, because then like you don't have random access, I think. Uh, which means, and what that means is, what do I mean? Maybe I don't need random access. Oh, but then it's linear time for inserting for a linked list. Um, so then like, which is maybe okay. Maybe that is the same as. Well, maybe you're right. Yeah. Uh, No, I mean, I think you're actually onto something there. I wasn't. I mean, yeah. At the end of the day, we're talking about the constants on the end log n, because when you go over the list, that would change. Uh, I mean, you can probably play around with more complex data structure, but I think the constraints such that you don't have to. Do I? Yeah, I hope I'm not well. Um, but yeah. Okay, let me just code this up and then we'll see. I think so. Yeah, maybe I'll do it in heap because I think uh, uh, I don't know. I just feel like that's the lower variance uh, uh, coding thing that I'm gonna do. Because I think the other thing is, if I do it any other way, it may be, I don't know. Yeah, I mean, I just worry that if I do another way, like there may be some edge cases that I'm not familiar with, and sometimes you just have to be, you know, you have to do the thing, use the tool that you're familiar with. Okay, so, so that, mm, always forget syntax. Mm, something like that. Oh man, no, I'm thinking of something else. But oh, so it's largest first, but we want the smaller number. So okay. Okay, just gonna make sure that this is what I expect it to be. Oops. Maybe yeah, I might have confused Python to a heap key, something like that. Maybe. Okay, this seems roughly right. Okay. Um, so deepest is so wow. Okay. Hmm. I think the only thing I have to make, so I'm just giving a thought just to make sure that I implement them in the right order. I think we do the pop first as a result of it being negative to as a tiebreaker. So I think that, which is the, yeah, the reflection, the, it's just what we need. Like, for example, if we have like something that goes from 10 to 20, and then another thing that goes to from 20 to, I don't know, 25, um, it should only have one at the highest because the 20s don't actually overlap. So you want to get rid of the 20 at 20 first. Uh, yeah, should be okay. If not, we'll play around with it. But we don't care about the results. But oh man, what did I do? The other way, but yes. Oops. That's unfortunate. um, yeah, heap is easier to implement also because someone has done it for me. uh, yes, these right, so 10, 20. I do it backwards. I always forget which way I wanted to sort. Okay, so 10, 20. So this is more right. And that fits. Do I think now I have to actually be careful? Oh no, it starts with smaller, bigger. Huh. I think I just confused myself too much a little bit. Um, well, let me try anyway. Mm-hmm. Guess I give it that print. Okay, that looks okay. Fingers crossed. Only thing I worry about is one time. Heap. Yep. Okay, so now I guess we have to get a little clever then. Um, hmm, I thought it would be a bigger case, but I guess 400 is not that big. Let's see how long it takes. Maybe it just gives me a timeout. But, uh, huh, what? It's alright. I mean, this one's in time. Is there. I guess maybe there's just a lot of cases in that sums up to it being out of time. I guess we have to do slightly more clever then. Um, hmm, let's think about it for a second. Uh, I was hoping that I would just get away with it, but I think the problem with and these are things that a little tricky sometimes because yeah, depending on the system you're implementing on, sometimes the time limit exceeded represents like one test case, where some other systems it represents the total amount of time for all the test cases. So which sometimes they don't tell you how many test cases there is, right? So I think within one test case we're definitely fast enough, but it's I guess in this case we have enough test cases that we have 98 test cases, then maybe it would take too long for if each of them are kind of on the airship things. Um, okay, but I mean, was hoping that would be this short, but yeah. Okay, so let's think about what that means then, right? I mean, there are definitely some. We're definitely doing over. Uh, uh, definitely doing extra work because we probably can take advantage of the fact that the system doesn't change that much and we're adding certain things to it. Um, but hmm, so yeah, so doing because this is n log n, so doing n log n on each book seems like we have to be at least faster. Um, is O of n fast enough? Hmm. And I think the other thing is also we have to think about what does it mean to end, you know, insert insert a segment, uh, and whether we can kind of take advantage of some stuff. Oh, yeah, okay. Just want to make sure. Okay. I think so. Yeah, I'll take a little bit better. I think what I'm thinking now is well. And I think it probably comes down to some sort of. I want to say that this kind of reminds me of what was it called, like quad tree type data structure, or like a tree type data structure, where, um, but also try to figure out how to incorporate that, right? Um, what is it called? Segment tree? No, that's what, maybe. And hmm, but essentially, I mean these are log n operations, which is fine. Uh, but I think the thing to note when we insert something is, yeah, I mean maybe we just have to do that linked list e stuff. I think Python actually supports it anyway. But when we insert something, you look at the neighbors, um, or where it fits in, and that can the answer can only go up where you when you're inserting. And now we have to represent that in a data structure that allow us to do it in hopefully log n time, but um, and then also set up the data structure so that you can iteratively do it. Okay. Hmm. And I'm trying to think if an array is good enough. Uh, hmm. We could definitely combine some of these. Uh, and we can definitely cache some of these answers, but also break them. But hmm. This happens. I'm also just trying to work out the complexities in my head. I think so. You can insert things in log n time, but then it takes a log n to get like a sorted list out. Is that work? Hmm. Also, my concern is switching languages. But okay, let me play around with some stuff. Hmm. My finger. Some C++, ST, there's what's that function name? Lowest or something like that? Lower bound. So I could probably use lower bound. So I think one thing that I just like doing in general is, especially when it comes to trickier problems, to do as little manually as possible, so, because there's just more room for mistakes. Um, so lower bound would probably come in handy. Yeah. How do I want to do this? Okay, I think I have some idea. So, in it's basically we want to kind of, I think as I was saying, similar to what we did with the heap sort in concept, but we want to have a data structure that take advantages of it, right? So when we insert a event, we want, uh, um, I guess uh, um, the last event that's smaller than or similar or the same as this number, and then increment one to it, and then uh, similar but the opposite for the end of it, and then insert an entry into a sort of a tree set type thing. Uh, the naive solution worked for you, or oh, also high note too. Uh, did it work for you? Or I don't know. I got time out. That's why I'm doing it now. I don't know if you saw me doing it earlier, but but that was naive. And that's I mean, and I could even show you when I ran this on this example. Um, I did anyway. Yeah, like it went in a second, but I mean, when you say naive, do you just mean like you insert it and then you kind of so like O of n maybe? Yeah, maybe you're right. Yeah, maybe. Yeah, no, okay. Let me try this again. Then, no, too. Maybe you're right. I think the other way to go about it is, uh, maybe I'll just overthought it a little bit. I think also, because I think lists in Python also has, it's like a pseudo array. Is that a or something like that? It's a what you call it. Well, it's a list, not an array. So it probably handles that for you. Wait, really? Yeah, time to sort. I mean, this one is just slow. Mm, what if I do something dubious then? Let me not even use a heap then, just for fun. Um, mm, right, I was ready to do something more crazy with login, but let me try this before I really dig deep into it. Um, I wonder if sort is also like optimized for this as well. Like if it's all like the idea that it's almost like if it's already almost if it's almost sorted, maybe it takes much faster than unlog in. Maybe it's smart enough to do that. I don't know. Does that kind of make sense? All right. Actually, I guess in this case, I just print it out just in case. Wow, you're right. This is much faster. Maybe the almost. That's interesting. All right. Well, I guess let's see if this is actually roughly right. Maybe it's roughly right. I don't know. I don't know how any of these bonds work. All right, fine. Let's just try again. And this actually, in fact, this was really fast. Because I guess the time was spent printing. But, huh. Well, I guess I tried to do the cool thing. Well, first of all, thanks now too for kind of the hint. I don't know what to say. So you'd think, I mean, I have some ideas. It's just that I think I protect against the worst case sometimes. Uh, but yeah, I mean, I don't think that's it per se. I mean, that's definitely a part of it. I think that I, I think I would actually say that it's probably related to the sortiness of the thing, where like it's probably because we do heap sort, it's almost like you have to look at like it's actually like it's bounded, right? Like every operation does log n, and so it's n log n like probably very tight n log n because you have to do log n ish operation every time because when you take off the top, you like it could go over and bottom. Where I think in this case because this self dot heap actually this is just a bad name now. I looking back, well not looking back because we just changed it a bit, but I think this is because every time that we do this sort, we have uh, we have uh, we have an array that is sorted minus two elements, right? So I think like maybe there's something that's sortedness, and I think some of that is maybe Python. Uh, uh, yeah, Python it doesn't use array, so it just does some magic there, and I guess no. I mean, I think now that I think about it, excuse me. I mean, I think now that I think about it, you're. I think actually Johnny mentioned this earlier, and I probably dismissed him a little bit because I didn't really think about the bounds in this regards. Um, but if you think about even just using let's say you're using a dumb naive bubble sort, and in this case, because the sortedness is almost like it like literally the only two elements out of place, right? So that means that if you use bubble sort and you sort or yeah, if you use bubble sort and you bubble just these two numbers to the right place, um, yeah, okay, maybe you have a lot of swaps, but it's only 2 times n, right? So you only need to run bubble sort, two iterations of the bubble sort. So in that case, in that realm, so you can actually even optimize that a little bit more in theory, because I just don't know how this gets. I mean, have some idea how it's implemented, but I don't know how like it actually codes it for in terms of like these kind of strange cases. But if we analyze it that way, let's say we did it from scratch and we use bubble sort instead. This is actually like 2 times n ish, so like O of n for this bubble sort, and then this is obviously linear, so this is O of n. So actually, in that world, we had 2 iterations of the bubble sort here. This code would actually be O of n instead of O of n log n, which is log of n improvements. Yeah, improvement. But yeah, and I think like to some degree, sort probably like is smart enough to terminate things in a little early or something like that, instead of doing like a full n log n sort. So that's probably where the speed comes from. Um, but yeah, there are also probably. I mean, to be honest, I'm not. I don't necessarily understand how Python internals work with respect to how because there are a lot of possible places for optimization with respect to arrays and lists and so forth. So I don't want to speak too much of it, something I don't know about. But I think like even without knowing that, if we reframe the problem or solution rather as a bubble sort that runs 2 iterations, then yeah, and I think wow. And I didn't even, to be honest, yeah, well, I mean, I like this problem as a result of that. I think it actually forces you to think about things you already know. I mean, people should be familiar-ish with bubble sort or some one of those type of sorts. Uh, I mean, it doesn't optimize for uh, hmm, yeah. I mean, it doesn't optimize for what you call it. It doesn't optimize for the number of swaps necessarily, but your complexity is a log n thingy. I think I definitely was a little, uh, I hastily dismissed this sorting part as n log n, but really thinking about can we do better on the sorting part? Because I think something that you just take for granted, or at least I take for granted, is that sorting, oh, it's n log n, so let's just do this other thing, right? Um, but actually, like if you only want, you know, like almost like, there are linear ways to, if you make if you actually understand the context of which you put it, use these sorting tools, then maybe you don't, in this case, I mean, it's, yeah. So I think like that forces you to analyze things in a way, and asks you to contextualize the tools that you have in a way that maybe is novel, or at least just maybe uncommon. So I think I actually really dig this problem as a problem solver, or whatever you want to call me. But as an individual question, I mean, I think this is, as a result, I actually really like this as an interview question, as someone who's as an interviewer. I think, I mean, I think there's some improvements around like, kind of, and some of this, because an actual interview is interactive, so that will kind of smooth things out, or smoothen things out a little bit in terms of expectations. But just having the balance and stuff like that in a good place, I think. Yeah, I mean, I mean, I do dig the thinking that gets you to the solution. Um, but and in an actual interview, you actually talk about how you arrive at it, and not just like, oh, I have some code and hopefully it works, right? So that would kind of come out. My only hesitation would be that this maybe is a little bit too little coding for a 40-minute or an hour interview, and in that, like, there's only 10 lines of code, which, or whatever it is, 12 lines of code, which makes things a little tricky to see, how someone, I mean, it definitely demonstrates someone's problem solving ability, but maybe on the coding ability, I'm not so sure that I would learn that much about it. But I'll have to think about how maybe ways to kind of modify this to make it more interesting in terms of programming. But I think I really dig this problem, and thanks again now too for, man, I'm excited. Yeah, definitely. I don't know if there's a easy way to share your code, but that'd be kind of cool to see kind of what optimizations you're doing. But yeah, because I think, well, I mean, by not sorting, I assume you mean just like doing some sort of insertion, insert operation. And I think, yeah, I mean, there are definitely ways I can, that I feel like are easy to optimize. One is maybe the insertion if you use linked lists or something like that. I don't know how the trade off is with uh, random memory and stuff like that versus whatever. So, um, but I feel like even then, like we could actually cache this, so that this, you don't have to run it for the entire array. So you still have to probably run it for the segment that you overlap in. So I don't. So at least in terms of the big O sense, it's the same. But there definitely some optimizations there. Yeah. Hmm. But yeah, well, yeah. Thanks again, L2, for kind of giving me a heads up. I actually was about to do something like really complicated, as you kind of see me do, and it saves me a lot of time. Um, cool. Yeah, yeah. Enjoy this file. Okay. Oh yeah, yeah, yeah. There's some. I don't remember how when I picked it up, but I definitely remember at some point I not this farm obviously, because if I did I would know how to solve it. But for intervals, I think the events. Yeah. I mean, I think in the end of the day, they're all the same, right? Like you're saving a few operations or something. I think the thing that I always strive to do a little bit is, yeah, it also makes you like just less error prone, because I don't know, like the less you have to type, the clearer it is. And this, I don't know, I guess I just worked out over years, and I don't think I came up with it. I think I just probably saw it somewhere, that like, allows you to, my philosophy is the less you type, the less you going to make errors, and the less mistakes you make. And I make a lot of typing mistakes, so especially in Python, where it's not a type language, and lets you do things. It does work. Uh, Let me just take a quick look then. Uh, uh, oh man. Oh. I actually not familiar with. Oh man. I'm very lucky that there's no like not safe for word ads. I never know these things, and I'm gonna get in trouble or something. I don't know. But cool. I think bisect is a thing that I definitely read up on somewhere, but I just kind of, I think I need to actually do it to learn like because I think I alluded to this a little bit in yeah, exactly. I was gonna say I alluded to this in C++ lower bound, but actually I'm not familiar with bisect, but I need to uh, yeah, well, one of those. But I need to. I mean, the the more tools you learn, the better. So I think that's cool. So yeah, I mean, I think this is like similar to what I was thinking about doing, except on C++. Except for I didn't know if this was going to be fast enough, so I was going to do some crazy thing with segment caching type thing. But so it's good to know that it works though. Thanks again, No too. We'll definitely read up on this, and hopefully, in the upcoming streams, I'll try to use it more. It's something that, yeah, I mean, seems like it'll be useful because I do binary search in silly ways sometimes.